All right. So, welcome to class 3 of ODSA Python 101. And today we're going to be going through some scrapers, getting some stock data, and exploring APIs and the projects you guys have been working on. So, moving over to the PowerPoint. So last class we did Python overview, breakdown of various language features. We went through and did some dissections of various programs that I've done, and a little look at some of what you guys are doing. We've practiced using Jupyter, and we looked at using the Google variants of that as well. And we talked about pseudocode and the project's assignment. This class, we're going to be looking deeper at the projects and kind of what that entails, how we want to structure that, what libraries we're going to use. We're not going to be talking about the getting help because we actually did that last class. I was able to fit that in. But we are going to be getting a lot of data, looking at APIs, related concepts, talking about regex and HTML, CSS, JS, what those mean, what those entail, and then basic web scrapers and APIs. So, project outlines. Hopefully by now you've started to flesh out kind of the functionality that you want from it. And whenever you're starting a project, it's really easy just to think big. But very often you want to start with what's called the minimum viable product. And that's the minimum amount of features that you need for it to work at some level that is useful, right? And so in the case of a recommender alarm, right? Maybe it's as simple as setting it to grab the weather daily. And then in the case of a single type of weather event, it sends you an alert or an update to do something, right? And so that would be full circle in MVP. Not as detailed as it should be in text, but all right. And I stopped at getting help for some reason.
Jonathan?
Yes?
I just want to double check. Getting the Google Drive, I was opening Slack just to see if anybody responded. I know it was on a different computer. Did you get my message on yours?
I figured you didn't get my message.
Well, that's one. Should I just be on cohort 10?
For the Slack?
Yeah.
Yes.
And
Yep.
the latest information I have on there is just July 28th.
Well, so if you go to the Google Drive, under ODSA10, yeah. I'll post a link to it too. And did I close it? I closed it. All right. There's the link for Google Drive for this class.
Google Drive folder for cohort 10 will be going on with it in class. That's from July 28th. Is that like not good?
So if you follow that and explore through the folders further, you should be able to find what we're working on. But if you open Slack to cohort 10, the most recent link that I just posted, that will take you to our folder that we're working with
But
today.
is there something in the Slack that wouldn't have the most recent messages? And Slack's a whole different program, right? The Google
Well,
Drive.
yes, but I posted the link for Google Drive.
Right, but I'm just curious how come my messaging isn't. Oh, maybe not, I want to cohort 10.
Number one, you might
Let's switch to you.
Oh, yeah, because it's getting connected to that. Maybe mine's are wrong. Is everybody else finding more?
Yeah, mine are safe.
Hey, look at this, freeze, preview, and agree with the internet access terms to Wi-Fi. Maybe maybe I can get on.
Yeah, I was trying to get your sheet,
Yeah.
and that's what happened.
And
And then it was also in a different language as well.
Oh, interesting.
Yeah, I was like, oh.
Because at least I got my password. We might not need
So
that,
let
John,
me-
if I can just get to the, please review and agree to, so I just.
Also, even on the cohort one that I replied to today, that's what you got.
So I know I went after yours too.
Was it like form?
That's interesting, 'cause it doesn't
How
have
do I, well, agree?
what happens to the project information.
Oh, you want to use the computer, yeah, use our.
Are you doing code in Spanish?
No.
Oh,
No.
okay. I
Oh, no, so what that is designer.
Because I wasn't that good the last.
Just fill in.
oh.
So it's more like just,
I'm like, it looks like Spanish almost.
yeah, so they use that, there's like a lab generator that fills in, just really hard. To help see that.
Okay, so now Google right there.
You see what it could look like.
Oh, that is, thanks, sorry about that.
You're good.
So,
Lorem ipsum.
yeah, exactly, yeah, tons of that. So let me change permissions, so that way you guys can see more.
I thought
You gotta say, what language was that? I was like, I don't know my phone.
I'm looking at like something like
I'm like, am I supposed to really know this, or did it like encrypt it so that? I don't remember that word about it.
It's like pig Latin, like designers will put in like pig Latin, just for boilerplate stuff, and that's how it is, but I'll change permissions, so that way you can view and that way you can make changes.
All right.
All right.
We ready?
Yeah.
Cool.
little side.
Nope. All right. So this class is focused on getting data, APIs and scrapers and more. So for starters, here's a bunch of open data sources. A lot of these you don't really need scrapers for. You just go in there, click through, find the data that you want, pull it down. And so you've got health data, you've got World Bank data, various open source data sources such as world.data, which actually is not listed here. I should get that on here. 538, they've got a lot of interesting data sources. They're actually a data scientist group that does everything from election predictions to sports game predictions, and they have a lot of beautiful visualizations. And so, let's see, open data on AWS, so that's Amazon, data.gov, and DBpedia. DBpedia is pretty cool because it allows you to go through and find a lot of the data sources that you might be looking for. Some of them are paid, some of them are free, etc. Right. Kaggle. Kaggle is a great website if you want to practice your data skills. That is your data science skills on various data sets. And let's say I just click over here. Here I can find all kinds of data sets listed with tags, pictures, and they've got great search features, etc. And yes, there's a getting started link as well. Terminology. So who knows what without looking at the screen too long, who knows what HTTPS stands for? Yeah, well, yeah, you looked long before this class. Okay, so Hypertext Transfer Protocol. So hypertext simply meaning a above form or a more complex structured form of text. And then transfer protocol, pretty obvious meaning there. And then secure versus non-secure. And so HTTPS tends to use some sort of encryption protocol, whereas HTTP does not. Okay. API stands for Application Programming Interface. And so it's something that, whether it's a machine, it's a software, it's a service that you're working with online or on your device, it allows you to write code to interact with the data and the functionality of that device or service. And so thankfully, most APIs are built now with Python variants. And so Python has become a very, very useful language in this case. Where there aren't existing APIs to get data from, you can also use web scraping, which is the drawing of web page data and then the parsing through that to get the select data sets that you want. And when looking at, let's say, complex market data and trying to understand unique variables when it comes to usership or analyzing user feedback and response and market sentiment, all of those things you tend to get at with web scraping. And then the idea of a spider, who knows what that is? Or a web crawler. So that's simply web scraping and or API interactions automated. And so a web crawler will go through on a page that you started out on, and it'll perform a set scraping procedure that you define. And then based on the number of links that it finds within that page, it'll go to those other links based on however you define those rules and search those pages for the same data sets. Okay? And so a web crawler can be very, very useful when you don't have the time to find all of the links that you want to gather to put through your scraper, and you want it to find all of that extra data or those complex interactions for you. And then HTML, CSS, and JS. So these are acronyms for the three sort of languages, or let's just say syntaxes that are the backbone of the internet. HTML gives it structure, CSS gives it style and color, and JS is what gives it its function. So HTML, CSS, form, JS, and to some extent CSS, function. And HTML stands for Hypertext Markup Language. And so that HT is carried in common with the HTTPS. And then CSS stands for Cascading Style Sheets. And JS, JavaScript. So very useful scripting language, heavily influenced the development of Python and many other languages. All right, so now we're going to work on building our own scrapers. And we're going to start by looking at what it takes to explore online websites and how we can find that data and understand what we want to parse out of that data. So this is just a basic structure of how you might often see whether it's a web scraper or a scheduled scraper that you've got. And so you've got a queue of URLs and a scheduler that passes those URLs to your downloader. And that downloader is essentially the scraper that scrapes those web pages down, and then it'll draw text and metadata from those pages into whatever storage device or system you have. All right, so that's the end of the PowerPoint section. Let's start by, actually I've got a page here, Omaha South High School.
Yeah.
Somebody might recognize this. This is the faculty page that I pulled up.
Did you just get that recently?
Yeah, I just pulled it up today, actually.
It's lovely. The retired teachers from last year are still there, so
Yeah.
all of I got to provide the updated staff. Not
Yeah.
very long.
No worries. So yeah, I just made sure to find this before class because sometimes you have to do a little digging. But things are nicely organized in rows and columns. And if I right click and hit view page source, I get all of this. Anybody know what this is? Yep. It is mostly HTML. There might be a little of JavaScript here and there and a little CSS here and there, but most all of it is HTML. And so this is what the page looks like to the computer before it renders it to what we see. And this allows us to go in and cut out different pieces. And so if I scroll down far enough, I find that there are areas of strong consistency where there's a lot of repetition. And there's a good guess that that's actually probably where the data is that I want. And so here's physical education, here's special education, here's international languages. What could those be? Yep, the subjects. And we've got Doyle Blake. And then we've got this from car code. That's very interesting. I've actually got to look a bit more at that. Oh, wow. Is that email obfuscated?
Is that what?
So sometimes to prevent people from scraping data from websites.
Yeah. So that they can't
Yeah,
spam us.
exactly.
Yeah.
And so what we see on this page is very clearly the email, right? We've got Jill Adler here, but if I go ahead and copy this email, let's see if I can find it. I can't find it. So that means that they are obfuscating the emails so that they cannot be easily just pulled. Thankfully, with a bit of reverse engineering, by looking at this, we could, if we wanted to, derive the email. And so this string dot from car code, this is simply saying that it's going to translate these numbers into letters or characters, okay? And so we could then get the email from that. It's a bit of extra work, for sure, but
You gotta scrape that.
Yeah.
The word is, right?
But the ending, like the last, how many of our characters should all be the same?
Yeah.
Validation that it's
exactly.
the same domain.
Very good point. But yeah, so there's a lot of ways to check and test those guesses when you have them. But that's pretty much what you're going to be looking for. And I should increase the size of this so it's more visible on the screen. Anytime something isn't perfectly clear up there, I may be fixated too much on my own screen, so give me a heads up. But yeah. All right. So that's what the data looks like from behind. Another way that we can look at it if we desire is we can say right click, and instead of view page source, we can say inspect. And on other devices or browsers, it's inspect element. But this also lets you look at the HTML in a collapsible and expandable way. And in the same way, I can look at the network. And if I hit refresh, I can see all of the files that are loaded to this page. Okay? And so when we do load a web page, we're obviously not just getting text. Behind that text, it's also calling pictures and files and all sorts of other things. So if I click here, I see, oh, it's a Google Translate icon. And I can click on other things and find those as well. And so you can build a scraper to pull much more than just data. You can build scrapers to pull pictures so that you maybe get picture radar and many, many other things. And so that's just to give you kind of a taste of, you know, how you can explore the inner workings of a page that you go to. Now, what happens if, let's say, I try to do the same thing on this PowerPoint right here? If I right click, oh no, it won't let me do it. Oh no, it won't let me do it. Ooh, I found a place I can. And so if I hit view page source there, oh wow. So what's different about this code?
It might be minified.
Minified, what do you mean by that?
What you can do is you can run something on your page to try to get rid of white space, things like that, so that it loads faster, maybe transmits faster.
Yep. Yeah, so very often what Google and Facebook and many of the other big names in tech, they will do is on the back end, they use really good clean code, very readable code with proper names for every variable and everything. But when you look deeply at each of these items, like A and B, and very, very short, distinct variable names, okay? you see that they're trying to use that space very efficiently. And on one hand, it makes the code run faster, right? It loads the page faster, it does all that faster, but it also obfuscates what is actually happening, what is actually on the page, in the very same way that those emails were obfuscated, okay? And so it makes it a lot harder to scrape any sort of useful information or elements from this data. And so the degree to which a page obfuscates or hides that information, you will have to know more and more JavaScript or HTML to be able to parse that out visually, like manually, and then be able to automate it.
Now, is that something, and I'm just seeing where things are coming, like 2 years, because that's when we went through class last.
Yeah.
Did you demonstrate that last time, or there wasn't as much of that hidden stuff? I mean, are people hiding stuff for making it try to run more efficiently, I guess?
Well, so
than they did 2 years ago?
there aren't a lot of tools. Like, so obviously for this page, for example, I wouldn't necessarily want to scrape things from it. For most Chrome things, if you're using data of your own or open drive functionalities, there are existing APIs that they will let you connect with their service and pull that data down from. And so for most of those big number cases, you don't really need it. Same thing with Facebook. If you want to access your own data, they've got APIs where you can access your own data. And at one point, I don't know if they do now, but they also had APIs to allow you to automate certain posts or messages on your behalf. And so there's a lot of different things that you can do once you know how to look for those APIs and how to build a Python program that can really work with those efficiently. And so, yeah, there's a bit of give and take on both ends, right? And ironically, https google.com, of all of the things that would be highly repetitive on this page that you'd think that they'd want to reduce, that's there. Okay, anyways, so that gives you guys kind of a good idea of what those pages look like and what to expect when diving into different pages. In the same way, real quick, let's say Wikipedia, Step Up franchise. Here we've got a pretty simple table, okay? If I inspect, we see a lot of TRs, which stands for table rows, and then T-bodies, which stands for the body of the table. If I view page source, scroll down, I can see much more clearly the text broken out. And in some ways, this is much more clear than the email sets. But whenever you have a scraper that's pulling down data, pulling this down, you're going to be cutting and snipping at these THs and TDs to get your rows and your columns. Okay, so probably a bit too much repetition on that note. Now we're going to dive into some of the different items. Okay, the first one we will open is, let's see. Okay. Since I've worked on this one most recently, I think we'll touch on the stock data. It's also one of the easiest ones to use. So click on it, download it, whatever you need to do to open it. And so here I've given 3 possible starting points. One library called Yahoo Fin, another called Pandas _data reader, and then Centex, who is kind of a prolific teacher of Python and somebody I highly recommend checking out for a highly varied set of just programs and automation, and whether it's stock market analysis or AI, he's got a lot of interesting stuff he's worked on over time. And so those 2 in particular start out kind of where these other 2 are starting, which is how to get data and how to then present that data. Okay. So you might notice that under Yahoo Fin, we've got pip install. So what does that mean we've got to do?
Import it.
We can try to import it, but unless we install it.
Well, we install
Yes. My question was the answer.
it. Okay.
That's making it a trick question, I guess.
Your thing must be not enough. Let's just go on.
Oh, yeah?
And I can't get to it yet.
Okay.
I'll try, but I'll watch like that. Went through this before, but
Yeah. Well, so this is using a couple of different libraries that I didn't use last time. These two I found over the weekend. And so Yahoo Fin, it's great at giving you live single points of data for any ticker symbol. And a ticker symbol is just the code that's used to identify corporations that are traded on the stock markets. And so here from yahoo_fin.stockinfo, I'm importing all functionality. And then I'm also importing time because I want to get some time functionality. And then I'm importing exists, which is a piece of OS, a file tool that allows me to figure out whether or not a file exists or not. And so I start by getting the quote table. And as soon as you pull that down, let's say I run here, imports are run, it's got in the table. And in that table, we've got now a dictionary of a number of variables and then data points for every one of those variables, or key values, I should say. Type dictionary. And we haven't gone through many dictionary methods, but that's what we're touching on next. Who remembers what a method is?
It's the behavior of the class. Something you can call that does something.
Yes, but normally it's very select to a particular object,
Yes.
right? And so a function you can pass variables into and objects into and all kinds of things into. A method is usually meant for either a very specific data type or a specific object. And an object is really just technically a data type or a data structure that the user defines. And so in this case, Tesla, the dictionary that we pulled from the web, has .keys. And a dictionary is a set of what? Two things. Keys and values. And so, or words and definitions. And so in this case, keys are just those words. So if I say for K in Tesla.keys, print K, I just get that first quoted bit. And so now I've got those titles without having to kind of dig visually through the rest of that text. And if instead I want to say KV in Tesla.items, should work the same. Yep. If I want to say instead that I want the value to be printed, I type in V, and then I get the values. And so .items is another what? Method, yes. And so what if I said instead values? What would values be?
So values itself is a method and it returns the list of values.
Yes, exactly. And so from the dictionary Tesla, it returns a list of values. Yeah. And so there we just kind of reviewed keys, values, and items. And so sometimes it's important to just be able to get one or the other. Sometimes it's extremely useful to have both and to be able to iterate through both. And so maybe that was like a bit quick of a jump for a couple of you, but yeah, simple iterator with a dictionary. Make sense? Cool. All right. So now looking at the next set. Here we get a lot more complex, a lot faster, which is definitely something I probably shouldn't have done in this case. But let's say once we've got this data point, we want to store it. Okay. When I say data point, I really mean the fact that it's a snapshot in time. Okay. So once we've got this snapshot of the quote price and the volume of that trading period, the market cap, and all of these different data points, I'd ideally like to record it. I don't want it to be lost in the ether. So first, I want to give it an extra bit. The one thing that's missing out of that entire set of data is actually when that data point was collected, which is sad, but it's a fact. And so here with time.time, you might remember the time module. I round that time to the nearest second and then clarify that I'm using the unit seconds, and I pass that to Pandas. And does anybody remember from the first day what I said Pandas helps us with? So think of the data that we're working with, or the spreadsheets. Not quite. That's all right. Good guess. So think of data as these bamboo shoots that are just growing up everywhere, okay? And as we go through this forest of data, okay, Pandas help us, just chew through it, munch through it, and work through it. So Pandas, in this case, I'm using to convert this time in seconds to a format called date time. And date time is kind of a special type in Python, a special object in Python. And in Pandas, it's very useful for indexing values and sorting through data really quickly. And so in this case, I had to build that to get this to work. And so with that, I then create the date time column, okay? And so whenever looking at a data frame, or even a dictionary, how you create that portion in that dictionary data frame is by using square brackets. Am I jumping really far, really fast? Okay.
I couldn't recreate it, but I'm
Yeah.
like frustrated as all get out about
Okay.
my technology and not being able to follow along. So that's part of my issue, but
Yeah.
strategizing how I'm living through the second time, but I could not read. That's because I'm also focused on.
Yeah.
I
So
wanna
to
pull the real
do
data that I want
a quick demonstration of what I'm doing essentially. Let's say I come up here and instead I want to do keys again, and I'll leave that as V just for speed's sake. Let's say I want to get the bid. What I can do is TSLA, square brackets, quotes, and bid. And by running that, then I got the string for the bid, okay? And so this is both a way of calling and storing values into it. So think of it as a box, and the dictionary data type allows you to store all of these boxes, right? And so down here, I'm just assigning that date time structure to that box called date time. And then, no, I'm not going to explain this part because that might be a bit too advanced, but I run that, it works well. And then coming down here, I now have a small data frame that only has the quote price and the volume from what was this larger data structure of all of these. Most of these data points, they stay the same from day to day. And so you don't want to be copying those 1,000 times if you get like data points maybe 1,000 times a day, right? And so we don't care as much about the 52-week range or the EPS, the earnings date, etc. Those will be the same. Same with the ex-dividend date. But yeah, coming down here, what I did to get that is using Pandas, PD, I created a data frame from Tesla, okay? And Pandas is really great at taking dictionaries and turning them into data frames. And so, let's see. So from that, now I've got the data frame. If I wanted to just run that, say df, that would give me all of this. To then select down, or first to set the index, because over here we've got a 0 and nothing. Went ahead and used datetime index, pd.datetime index set to the column datetime. And so that allowed me to just order whatever rows I pass into this data frame according to that. That way when this data frame, or this CSV, what it will be, becomes thousands of lines long, I don't have to worry about it being ordered by the left-hand column, which is just 0 to whatever, right? I can make sure that it's ordered in the correct way. And then here, so that I can skip past everything else and just select the things that I want, I give it quote price and volume, because very often those are the two most important data points to get. And so, all right, so do we understand how I got to here? Okay. And so the last thing I do, now that I've got it in the form of a data frame, is I pass it to a CSV file, okay? And this basic if-else statement just checks, number one, does this file exist? Does tesladata.csv exist? If it does, then go ahead and append to it. If not, go ahead and create it. So both of these are using df.toCSV. And toCSV in this case is a method, but what's different about the variables that we're putting in there?
The top one just adds it to whatever existed, where the bottom one.
Yep.
Adds it, so we don't want that header.
Yeah.
We don't want mode A instead.
And so what would mode A possibly stand for?
Add,
Yep, add or append.
append.
Yep. And then header equals none, what does that do?
That full price line is recreated.
Yes.
Just adds it under.
Yeah, it makes sure that these two lines aren't appended at the same time. Yep. Because otherwise, if this is gone, when you append those lines, it just boom, 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 boom. Yep. And so, thankfully, that makes it pretty easy from there. And so, if I go ahead and I run all of this, let's see, how far did I run? Ran that far, I guess? Okay. So I hit run, I come over here, check my folder, and now I see that there's tesla_data.csv. And so this is data that I pulled from the web, and now it's here. And we see that here's a price from an earlier time. Looks like this was 2 hours ago, actually. And we see the quote price is this, and it's the same right now. Why would they be the same? What's that?
Nobody bought or sold it or traded it.
Market's closed.
Market's closed. Yes, exactly.
Yeah, because the volume.
And so I'm actually kind of like bummed because earlier in the day, when I was double checking this code, it was running and it was producing different results second to second. And so this is actually a pretty useful API if you want down to the second feeds on the stocks that you're trying to get info on. And so for day trading or just collecting very, very, fine data points, right? Because a lot of the data that you can collect historically, they will be day-based data. They will give you the high, the low, the close, and the starting point for that day of trading. But beyond that, they don't give you the minute data unless you pay money. And so this is a way for you to create that data for yourself at next to no expense, except for the electricity, right? And so there's kind of a starting point. Let's see. So that's an example with that one. Now, if I wanted to read that CSV back into Python to make it useful, I could go ahead and run pd.read CSV, and then this one to read the head of that CSV, and we get that same data. All right. And is everybody like following along and trying to run the code too?
Yeah, I'm having a problem with the write. I think there's a permission with writing.
With writing what?
I get permission error when it tries to do the data frame to CSV. So there's permission error.
Let's see.
Yeah,
Oh, that's probably because of the folder that you have here. Oh, and it looks like you ran one of the lines many times.
yes, I did.
Yeah. And so you see how that can affect things when you.
Yeah.
Yep.
Because I wasn't getting feedback that I ran it, so I'm like,
How do you, because you know how you said you'd rather go through in conduct to report rather than in the system itself. What's the way of doing that?
So go back to the drive portion.
Like the Google Docs?
Yeah, the Google Drive. And then right click on whichever one you want to download. And then you got it.
But you know how you have to import?
There you go.
You know you can import Yahoo thing
Yes.
so that you can access it. And we did it one way, but you said it's better to do it through Anaconda last time because
Yeah.
it sort of puts it where it's supposed to be.
Yep. So I'll review it. I'll review it up here. So
And yes, I got all the way to Anaconda environment.
Yep. So when you're in Jupyter and you're ready to open something else, since we just want to kind of keep it all in here for now, the easiest way is to open a new terminal. And once it loads, call pip install, and then whatever you're trying to install. It really doesn't show up. And so maybe I want to install.
no, I'm sorry to interrupt you, but does this do it without a virtual environment?
So this is the base environment. It defaults to the base environment
Okay.
or root
Because what I noticed
environment.
is that when I did it through here,
Yeah.
it gave me the message prompt about having a virtual environment.
Okay.
I don't know what this is. We went away already.
You want to check into that after class?
Sure.
Cool. But yeah, so in this case, I would just go ahead and come up here, copy, pip install Yahoo Fin, in the wrong way, and paste, enter. In my case, it's going to tell me that it's already satisfied, and then it finishes. Yeah. And very often, whenever you see a module used in Python, it'll use underscores for separation of words. But then when you go to install it, it uses dashes. That's a really important note because that allows you to very easily go and try to test an installation if you can't find directions online for some reason. And so there's a YouTube video that kind of goes over the basics and some things you can do with it. But it doesn't go into kind of the deep functionality that I went to in how to save that data off. But let's see. So then we'll cover real quick how to do it with pandas underscore data reader. And ideally, whenever you're doing things with data science and long-term data, you want to work with anything that is closely correlated or working with Pandas. And Pandas Data Reader has huge support from the community, been around for a while. And so in this case, it's pip install pandas-data reader. There's some documentation links.
Once it installs, can you exit out of the terminal window?
Yes, yep. I just leave my tab open in case I want to install something else. Okay, cool. One other thing that's useful to know, if you've still got the terminal open, is if you type in conda list, then you get a list of all of your libraries and modules that you have installed and the versions of those installations. In the center, you see the versions of that program, and then on the right, you see the version of Python that works with.
What are you typing?
Conda list,
Let's just call
space list, sorry. Right here. Oh, I'm great at this. Yeah. Okay. And sometimes too, that can be a great starting point for exploring what other things you've got on your device that you had no idea of. I've spent maybe a bit too much time going through random lists of Python modules to figure out all the things that I could do. But Pygame, for example, extremely useful library for building games or even apps for that matter. Some earlier versions of things that I would have play sound or music would actually use Pygame to start that music. But it can also allow you to create interfaces for that as well. PyQt, helpful in creating user interfaces, data util, etc. You might notice that we've got regex and requests and scikit-learn and scipy. And then Seaborn is something we'll probably touch on in a couple of classes. That has to do with visualization. And so hopefully we can get in some good visualization of data. All right, anyways. So looking at pandas_data reader, very often you want to stick to conventions that you see people use online when doing imports. And in the case of pandas, we import pandas as PD for the convention. So in the case of pandas.data reader, we would use PDR, just for short. And so they've got a built-in tool for Yahoo Finance, and they get historical data. And so instead of maybe building your own custom scraper that goes out with time parameters and maybe uses URL to get data, you would go ahead and just type things into here because it's already built for the Yahoo API. And so here we're just putting in a ticker symbol, a start date, and an end date. And we're passing it from PDR to this Tesla data frame. And once we've got that data frame, we can check it out.
So this would be the same thing that I would use, not grabbing the Tesla data, that would just apply to CSV files that I shared as examples in my folder.
So if you're using CSV files, you won't use Pandas data reader. That you'll just use Pandas.
Okay.
Yep. Pandas data reader is useful for getting financial data and data from existing APIs out there, as well as some other, unique, like physical data that you might have on your machine. But yeah,
Well, and that's why I'm saying that if I export the transcript data, I mean, I can't go straight into Infinite Campus and grab it.
Yeah.
Because of the security rights.
but what file would you export that data as?
I think my own options are either, PDF or Word or
Yeah.
CSV.
And so here in a minute, I'll go over some of the options with CSV and PDF.
Okay.
And so,
And CSV is probably.
Yeah. Yep. Okay, so that gives us pretty quick data frame, date as the index, high, low, open, close, volume, and adjusted close. By the way, who here knows what the volume is?
What it means.
Yes.
Yeah, I was gonna ask that question. So, I mean, other than
Yeah.
the quantity of transactions? Well,
Yeah. So,
Yeah.
so the amount of transactions that are occurring over that period of time. And in this case, it might be, actually, do you know whether it's the monetary value that's transacted?
That I don't know.
Because I was gonna
Oh
ask
my
that question
gosh.
earlier, but I thought if it's a one moment
I
in time.
have to have known this at one point, but
I don't think that it is, and the reason is because sometimes they talk about high volume, low volume, but they don't talk about that in terms of price, right? Because if the price is big, like Amazon or Class A would charge you,
Well,
that would artificially make it larger.
yeah. So the thing is, though, the volume can be extremely high, but the price can remain the same. And that volume can be high in theory because that's the number of trades that are occurring, right? Or that is the monetary value that was traded in both directions at that time. And so I'm trying to figure that out. Seeing as how it doesn't have a monetary value associated with it anywhere that I've seen, I have to imagine that's the number of trades. So,
But number of trades in that point in time, and it always goes up then?
in this case, we're just looking at a head, right? If, let's say, I just look at 1 year's worth of data, 19. But instead of going for the head, I tried to print out the entire data frame. This is going to take a second. Maybe not. Okay, so it summarized it anyways. Okay. Oh, that's mean. It should have printed out the whole thing, yeah. Because normally when you ask it to just give you the data frame, it'll give you that type of summary anyways, like that. But when you print it, it shouldn't be summarizing it like this. But what you can see that it did is it gave me both the head and it gave me the tail of the data set. Yep.
If you click on those three dots, that doesn't do anything, though?
Nope. Good question, though. All right. So there's that. So now that we know how to get that data, we can build a function to do the same. And so here, I just call it get stock data, ticker, Tesla, and what are these values that I'm putting in here? Do they mean anything? What's unique about these values over values that I put in here?
Oh, those are the defaults.
Yes. So whenever we're defining a function, we get to state a lot of things about it. I can leave this completely blank, and I can just say that there's variable ticker, right? And you can put anything in there to be that ticker. But if I say that it, by default, is going to be Tesla, then you can either leave it as that, or you can put in a different string. And so when I call it down below, oops, valid syntax, colon.
And it's just a definition I ran into that too.
Yeah. Yeah, so if I do decide to call that, what I can do instead is say Apple. And then I can leave everything else blank. So if I run that, oh no, what if tolerance is not run? Key error date. And date start date. We're passing it in the exact same way. Oh, let's see. No, that's a correct ticker symbol. Did Apple change their ticker symbol, do you know? Okay. Let's double check this with Tesla. That should work. Yep, that works. And then Google. That works. IBM. Okay. So we've got one that works, but it doesn't work for Apple for some reason. They now have a shorter ticker symbol. That makes sense.
Apple does.
Either that or APL is something else that I'm getting. And based on these prices, yeah, that is not Apple.
Yeah.
APL. Okay.
APP, or AAPL.
APL. Okay. There we go. I think I remember getting that wrong map before.
Can you tell if it's right at 147.06?
For-
It's like 15.
Oh, this is today's price.
Yeah.
Yeah. If I wanted to get today's price, I'd have to change one of these. So what's today's date?
Today's the sixth,
5.
8/5/2021. And it should be the closing price, right?
We can do 8/5 for the date. To May, August.
Oh, gotcha. Yeah. Duh.
Would you say that?
F5/8.
Oh.
And that's showing the head. Let's get the tail. And in this case, when we're using head and tail, what are those?
Top and bottom.
Well, yes.
It's putting it at
At a higher, more abstract level, what are head and tail? I've asked the same question many times today. They're methods. And in this case, they're methods specific to the data type, data frame. And so,
So I think if they're worded well, they're very descriptive and you kind of skip past that third method.
yeah.
147.06. That's where it's ending.
Yep.
Rounded.
Yeah. But you see, I get accurate data. You get rounded data.
You get it out to the sixth.
Yeah,
digit.
that's actually impressive. But many people make and lose millions of dollars based on those fractions of a cent.
Oh, yeah.
And so, yeah. Okay, so that at a basic level is how you get data. There's probably 2 or 3 other ways out there to do it. I left
How would
in.
that volume change there? If you tell anything from the volume based on this data? No?
It looks like the volume. Okay, so these are the last few days. This is going back. So over the last 5 days, the volume has almost gone down by about 60%. So
Well, the price has gone up.
yeah,
Volume down,
so that's
price
a
up.
good sign actually. That's a very healthy sign to see in a stock. But I think next week, since I'm whetting the appetite, looking at all these numbers, we're going to visualize some of it. Yeah, I think we'll just jump right to that. But if you want to take your own looks at this and listen to a favorite teacher of mine, Centex is awesome. This one gives a good primer on how to get some Yahoo Finance data. It's a bit old. You can use the technique that I've given you here, the couple of techniques, and still get the exact same results and sort of data sets and data frames that he's working with. And then this one goes and starts into visualization. And so if you want to take a peek at that before next week, you can as well. Oh, dang it. Didn't mean to do that. And a moment. Un momento. Okay. So there's that one. That's musical. Close that. Okay. And where I want to be is over here. in Drive. Okay, so we took a good look at a couple tools, Python-built tools that connect with APIs. And now we're going to look at a couple other things. API requests and this request example. Okay. Sweet. So I built this for this class a while ago. So I have a habit of rebuilding lesson plans time and time again. Sometimes I build over each other. And so this IPython notebook is going to look similar to the other one, but this will cover a lot more. Okay, so we already know what APIs are, but there are APIs that follow what's called a RESTful type framework. And to learn more about that, check out this YouTube video, but we will not be covering that necessarily in class. So URL, Uniform Resource Locator. Didn't realize it had full name, did you? And then there's URI, which is more kind of specific. It talks about the identity or the identification of a resource. API, we already know what that is. REST, representational state transfer. It doesn't help you understand the meaning of REST, by the way. But RESTful APIs simply mean APIs that are built in a way that are meant to be easy to interact with, and they follow a relatively consistent format of interaction between each other to make that use easier. Okay. Request and response protocol. And so anytime we open up a web page, what we are doing is we are sending a request out into the internet, out into that chain of communication that we talked about in the first class, and we get some kind of response back. Sometimes we get a web page, sometimes we get a picture, sometimes we get a 404. Who knows what a 404 is?
Error message.
Yeah, so it's a specific error message that says that the resource wasn't found, that we don't know where this web page is. We don't know where this resource is.
Kind of like I could say it wrong before I can't get
Yep.
password to go through.
And then a 403, very close to that, is forbidden. Like you are not allowed to make this request. And then there's a 500, which pretty much is telling you that, hey, we're kind of broken right now. We don't know what's going on. We're having a server issue. And so this idea of request and response is just whenever you put in the URL, you're putting out that request to the internet, and they send you something back, no matter what that is. So thankfully, in Python, we have something to handle the complexity of requests. Requests, when you look at them, they're actually structured with headers and many, many other pieces and data points and bodies. And to handle those structures, we want to use requests. So here, I'll just run a few imports. And this is actually kind of lovely because right now I'm running this in the cloud on Google, and I'm not necessarily expecting all of this code to run as it's just running, but it was able to import all of those, and now I've defined these functions. Just looking very briefly at the titles of them. This one is for getting HTML. This one's for downloading. Clears tags, gets text, gets links, and this is another function that gets links as well, but looks like it needs some fixing. So, okay, so that is defined. Now everybody open up solvearth.org so we can look at this side by side. Okay, so that's what the web page looks like. And I've probably got too many of these open.
said solveearth.org.
solveearth.org.
One E, we solve on Earth.
Yep.
So SOLVEARTH.
So I didn't clarify that. Yep, so here I'm just defining a couple strings that hold these links for us. And then here, I pass the URL. Oh wait, I'm looking at HTML on the site. Okay, so the download functions, we didn't look at the functionality, how it works. But how it works is it passes the site variable, which is the URL, into it, and it makes a request to that, and then it spits it out into the file name that you define. So in this case, we are making a request to that very same web page, and we're creating the file solveearth.html. If we run that, then we get all of this text back. And so you see a lot of slashes, you see various tags, and that's just kind of the structure of the website. But we see some things that we might want to get out of here. We see a link, we see various words and pieces. And to get at that, we could use one of the functions that I have. So in this first one, get text. Wow, is this broken? Oh, no, I'm using this as an example. Duh. So in the first case, we take a look at get text on CNN.com. And it does not work well. Because even though what getText does is it clears tags, it doesn't necessarily clear a lot of other types of text and structures. But if I wanted to instead do solveearth.org, no, I'll break in a second. I promise. Yeah.
I know you.
After this example, we'll get break. So after putting in solveearth.org, you can see very clearly that we don't have all of that extra stuff, right? So that's kind of the difference again between some of the more large corporations and the websites and the infrastructure that they've put in place and smaller sort of self-built websites that you'll see out there. And so this is a website that I built a while ago, and that's why I like using it as an example, because I know how it's going to function. And so thankfully it kept all of the white space, and so it allows you to see a bit better the actual structure of the page and the information. And so
That's the kind of code behind this solveearth mapping what matters.
yeah, this is the text behind the page. Yep,
Is it just, then this is just the home page, right?
just the home page, yes.
Okay, they're solving IT. I was like, what's all that? That's the things down below.
Yep.
So I was like, I was gonna ask questions.
Yep.
But the resource, I gotcha.
And
That
so
shows at the bottom of the page.
So that's kind of the starting point. This pretty simply just gets links. And so here you see a very quick list of the links that can pull. So over the break, we'll break for 10, maybe, well, let's do 15 minutes since we're starting it a bit late. Explore the code, okay? Try to see if you can parse out what these functions are doing, okay? See if you can understand the logic flow, okay? And then test and experiment a bit. But, all right. Break.
I changed access to the website, so if you want to try to get the portion on
Your break, can you go back to that page second?
Yeah.
And so then I just ran that, and I just was like, oh, let's use this one, choose that, and I just really do a piece of detail out there. So I just kept changing it a little bit line by line. It includes a way of kind of planning, but it's also something that's familiar, right? Like, pretty much I was looking for all classes it down, how practice it up.
Yeah. So full screen on that, nice. So just to touch on real quick what I covered in a much more robotic way. So whenever you're exploring a library, you're really not going to need much of it. The uppercase items, they're flags. They will change things globally in the function of that module. Things with underscores, you're never going to touch them. And then the rest of this is where the core of that functionality is, all of which you may only ever use 5. And of those 5, 90-95% of the time, you're only going to use 2 of them. It's really about what you can act together for the functionality that you want, getting things to work for you. And so, great read tutorial, highly recommend it by Centex. Okay, cool. So next, real quick, and I don't know how much of this we're going to get through before Mara has to go, but we're going to try to do the same thing with the school URL that we did with the others. So if I come up here, nope, we're down here. All that's defined. I'll rerun this one, but instead of using what I've used already, I'm going to change this so that it's South OPS, and I'm going to change this from sites to South. And let's see what that HTML looks like, just as expected. And then if I want to get the text for here, again, South. Okay. So this is much more legible than what we were looking at otherwise. We can very quickly at a glance see who works where, but we've got some double slashes that we'd want to parse out and a lot of white space. And we'd still want to figure out how to capture those emails, right? And so let's look really quickly at what that's doing. But real quick, just for the sake of seeing how it works. Oh, we've actually got some phone numbers here too. I love phone numbers.
Oh, right.
Yep. And so those are definitely going to be school-based phone numbers, but still, if you're scraping and you see those somewhere, you want to make sure that you've got a data space for that. Okay. And real quick, just to see what links this produces. Ooh, we got an error. href, hit herself. Links, get links, HTML, key, 2 frames missing.
Where was that get links code that you put in?
So this get links code,
Oh, okay.
I wrote in just here, but this references back, and you don't see it in here until you click these 2 frames to expand. But that references back to here, which is in a function above that I have. And URL href, okay. And that href.
Error too, and I know I ran successfully earlier.
Yep. Yeah. And so there's something fundamentally different about the tags or one of the URLs that is causing it to throw an error. And so the error might be fundamentally in the code that I've produced, or there might be a special exception within the code of the web page that just makes it really hard for this piece of code that we've made to parse. And so let's see, for A and A tags, A-ref, okay. Okay. So to explain how I'm reviewing this right now, so get links refers to the function that I built. This is code within that function. And this line that it's referencing, I'm trying to build a list of URLs, okay? And I'm getting this list of URLs from the A tags, which is a fancy way of saying the tags that point to links within the web page. And I'm trying to draw the ones that are saying href, okay? And normally within a web page, such as Solve Earth, that's Facebook. Okay. Advanced. Proceed. If I do view that page source and I hit find href, you'll notice that all of the links here listed start with href equals quotation mark and then the link, right? And you also see right here that A that was being referenced. And so that A is what that A tag is, and that's normally how most all links are stored within web pages. Okay, so if we go, however, to the other web page, scroll. That's a lot of data. Oh my gosh, sorry. And here we are. Normally there's right-click optionality. No click and drag optionality. Okay. So if we do the view page source here and try to make sure that we're looking for the same thing, href. Okay, we've got some hrefs, good. But they're not all using an A tag. This one, for example, is using a link tag. Link. Okay. And a couple of these. Let's see, does that have an A tag? That one doesn't even look like it has an A tag. It's highly obfuscated if it is. But, so that means that we have to also include things for that other type of tag. Make sense? Okay. So, in this case, we'd be looking for link. Okay. So we'd come up and modify the function that we've got. And that was in get links. Okay. So this is the function that produced what we got before, which was that list of links from the Solve Earth website. But because this other one doesn't seem to have any, it's throwing an error. If we change these A's instead, oops, geez, to links, and it's breaking all over the place. Let's see if that works. Still error. Link is not defined. Wait. Okay, one frame. And clearly I'm not reading through my entire code correctly. A tags for A and, oh, duh. So, link. And soup find link. So, does that make sense why I just missed that? Yeah. So I tried to change a variable without really paying attention to where that variable came from. But where it came from is in this soup.findAll function. And soup is a subsection of beautiful soup, which is similar to re in that it helps you parse through a lot of data and information. And it's helping us find the tags concerning links. And so if we run that and clear this output, and then rerun this, here we go. Oh, very curious. So when looking at the page source, we actually see there's 7 of 148 hrefs, only a few with links for references. There are still a number with A tags. Okay. The beauty of HTML, right? So I would still have to do some digging but the fact that I didn't get errors with links as opposed to the A tag, the link tag versus A tag, shows me that there is something wrong with one of those specifically. And it may very likely be that there's an open A tag and not a closing A tag somewhere. It could be in the HTML code. Very often, whenever you open up web pages, your browser will get anywhere between 0 and 30 errors.
What's
Okay.
the difference in that shade of the href? Yeah,
Oh, this one?
yeah.
That's probably because that's the one that's selected under the find function right now. And to do that search, I just hit Control F. Yep. And that's Control V. Yep. And it'll just highlight all instances. And sometimes whenever I'm trying to find information really fast too, like maybe I'm trying to look up research on a cancer treatment for a specific kind of cancer. And yeah, and I want to find a very specific piece of information within a long, boring document of research. I'll search for that very fine piece. Or I'll search for, maybe in the case of COVID and vaccines, I'll search for all references to zinc because I'm interested to know how much zinc is used as an adjuvant in that vaccine, right? And so, anyways, Control F, extremely useful. It'll save you many, many minutes in time. Okay. Yes. All good.
Well,
Yeah, my mom say it was. I just got finished up, but will you let me know if I can watch videos over the weekend?
Yes. Yes. I'll keep you updated. Update us on how the game goes.
I'll
So like I'll be playing time make and
Awesome.
Bye, you guys have a good weekend.
Later. Okay. Cool. So at this time, because she's gone, and if I dive into this too much, we'll go maybe non-functional. Let's focus on your guys' projects. Okay. And so I'll give us maybe a quick break to get set up on those projects. And the rest of the time will be more dynamic focus on your own projects and me coming around to help you guys find libraries and practice the Python. Okay. Cool. All right. I have a feeling I'm going to post a bunch of adjunct sort of links and resources for review. While you guys are doing that, I'm going to figure out this A tag. Okay. End stream.